today we are going to discuss about another technique for image compression, that is arithmetic code for image compression. It generates a non-block codes, one-to-one correspondence between the source symbol and the code words does not exist. Instead, an entire sequence of source symbol is assigned a single arithmetic code. Code word defines an integer of real numbers between 0 and 1. As number of symbols in message increases, interval to represent it decreases, and number of bits to represent information increases. Each symbol of message decreases size of interval in accordance with its probability of occurrence. So I am going to explain the whole process with the help of an example. So for example, we have a 5 symbol message, that is A1, A2, A3, A3 and A4. From 4 symbol source is coded. So the probability of A1 is, since A1 comes only 1, so 1 divided by total number of symbols, so that is 5. So probability comes out to be 0.2. Similarly for A2 the probability is 0.2. And for A3 it comes twice, so 2 divided by 5, so its probability comes out to be 0.4, and for A4 the probability is 0.2. Now for an initial subinterval we chooses for this one A1 that will start from 0.0, and it will start from 0 and goes to 0.2, and for the second step for A2, so this comes out to be starting point is 0.2 and the end point is, which is an open interval, is the cumulative sum of this probability, so 0.4, and the third point is the starting point is 0.4 and the cumulative sum is 0.8. Similarly for A4 the starting point is 0.8 and the cumulative sum of these probability are 1. With the help of this example, I am going to explain how arithmetic coding works. So on the y-axis of this one, we represented the cumulative probability density. And these A1, A2, A3 and A4 are the symbols. So now we are going to expand A1. So A1 lower limit is 0 and the upper limit is 0.2. So now we are going to expand it for A2. So with using this formula, that limit is equal to the lower limit plus the difference between the upper limit and lower limit into probability. So for A2, the lower limit is, the lower limit is 0 plus the difference between the lower limit and upper limit is 0.2 minus 0 into the probability at this position is 0.2. So for A2 the lower limit is 0.04. Now for A2 the upper limit is equal to lower limit. So lower limit for this one is 0. The difference between the lower limit and upper limit is 0.2 into the probability at this position, which is 0.4. So it comes out to be 0.08. Now for A3, the lower limit is 0.04 and the upper limit is 0.04. For the expansion of A3, the limits are the lower limit 0.04 plus the difference between the upper limit and lower limit into the probability at this position, which is 0.4. So it comes out to be 0.056. And for upper expansion, the lower limit is 0.04, that is the difference between the upper limit and lower limit, and the probability at this position, that is 0.8. So it comes out to be 0.072. Similarly, we are going to expand A4, and for A4 the lower limit is 0.056 and the upper limit is 0.072, and the limits comes out to be 0.0688 and 0.0624. The final message symbols narrows to 0.06752 and 0.0688. So it comes out to be in between this one. So here 3 decimal digits are used to represent the 5 symbol source message. This translates into 3 by 5 or 0.6 decimal digits per source symbol. In the next lecture, we are going to discuss about LZW coding for image compression.